Hello, my name is Govind Kumar, and today I'm going to show you my ML project. And uh, in this project, we load a dataset and preprocess it and use different models on it and find which model is the suitable for this dataset. So first, the dataset name is UJIIndoorLoc. It has 529 attributes, and the information regarding this. The 529 attributes contain Wi-Fi fingerprints, coordinates, where it was taken, uh, and other useful information. Uh, each Wi-Fi fingerprints can be categorized and by the detected wireless access point and corresponding received signal strength intensity. The intensity values represented as negative integer values ranging minus 104, and this value we will use in the data in the code 0. The position value 0 100 is used to denote when WAP was not detected during the database creation. uh, 250 520 different WAPs were detected. Thus, the Wi-Fi fingerprint is composed by 520 intensity values. So, this dataset contains CSV files, training and validation data, and this is the overview of the dataset. It does not contain any single. Now, the first what we have to do is download the data set from the site and upload it on the Google Drive in any folder, and then I'm using Collab. You can use any other Python compiler and anything else. So on Collab, we will mount the drive. I have already mounted it, so it's showing. So after mounting the drive, there is an option drive. There is a file directory that is showing drive. Opening it, and then all the folders to lab node. I have uploaded the training and validation data on this folder. So first we have to use we have to import pandas and numpy so that we can read the CSV file. So first copy the path from this and paste it over here. So reading the training data CSV and the validation data.csv. Importing all the required libraries that we will use in this code and modeling of the dataset. So first we have to train shape, value shape, train head, and train columns. Then we will concatenate the training data and validation data, the files, training data and the validation data.csv. Concatenating means combining or adding it. So first we have concatenated. Then we use here is the for how many users are there and the user IDs. There are 19 different users and the user IDs are here. These are the user IDs of the different users, entries per user, and then how many different phones are used in this. There are 25 different phones used, and the list of the user IDs are this phone IDs. So we first will group by use the function group by user ID and phone ID. User ID and phone ID connecting the user and then the phone ID and user ID. Then we will use relative positioning building analysis. Relative position of the first relative position and count the plotting relative position to the count, then building ID to the count building IDs, and then how many floors are there in each building. So one building ID and many floors are there. So we will now plot a graph of those to count distribution of entries by column. So for then the trajectory analysis, this we will list of building visited by each user trajectory, uh, user IDs and list of buildings. Then we will by floor and user ID floors. Then we will find the relative position of uh, the latitude and longitude, how many uh, Wi-Fi fingerprints are there in this latitude and longitude in every floor. So this is the floor C is equal to 0, the fingerprints relative positions, and the floor is equal to 1 relative position, 4 is equal to 2 the relative position, 3 and so on. These all are the relative position at every floor. So then after finding the relative positions, and we have to drop it, drop the columns of the so dropping the unnecessary column, dropping. Then normalization is required, so normalizing the Wi-Fi signals. First we have to normalize the Wi-Fi signals. I have shown you minus 104 0 0 minus 10 dB. Is here, yeah, this minus 104 extremely poor signal to 0 dBm. So normalizing the Wi-Fi signals, if it is unreachable, it is represented by red as shown, not detected, 100 at the value 100. Normalizing it, and then we have to train the cells, Wi-Fi cells, train columns, and normalizing Wi-Fi values. We have to normalize the latitude and longitude. In this we have normalized the latitude, and in this we have normalized the longitude. So normalized. Then we have to split X and Y column. Splitting X and Y columns. Then after splitting, we have to train the models. So our first model is a random forest model. This we have used a random forest classifier and random forest regression and classification, RFFR and RFC. After training and modeling the random forest on this data set, we have find the classification reports. So the classification reports of the building predictions are here. This we have found precision, recall, F1 score, and support. So in this random forest model on this data set, the accuracy is 0.91, and then we have used the SVM model. In this SVM model, we have used the types of a multi-output regressor, SVR, and SVC classification. So after training this SVM support vector on this dataset, we have find the classification reports of building prediction. In this we find precision, recall, F1 score, and support. The accuracy of this is 0.90. So then we have used XGBoost as our model on this dataset, and in this after the training on this dataset, we have used XGBoost, and then the classification of building prediction by XGBoost is this reports precision, recall, F1 score, and support. The accuracy is 0.91. So we have seen that the XGBoost and the random forest is giving the 0.91 accuracy, and the SVM is giving 0.90 accuracy. So the SVM and XGBoost, not SVM, the random forest and XGBoost are most suitable models on this data set as per my knowledge. So this is the code, all the codes, and my report is So now concluding the project, this is the report of the project, the abstract part. In this, the development of the multi-building and multi-floor localization database on land fingerprinting fills a critical gap in the research community. It ties comprehensiveness and public accessibility, make it an invaluable tool for researcher and fostering collaboration and driving this of indoor localization for mobile computing. Keywords. This is the pictorial representation of the data as I have shown you in the relative position and uh, relative, the relative positions and the floor on fingerprint of every each floor. So list of building visited by each user. So the result and description is first we have the data, then pre-process it and understand the data, find the relative position analysis and building analysis and trajectory analysis, then find the user movement on each floor and at the relative positions, and then dropping the unnecessary columns, then normalizing the Wi-Fi signals as per the information given in the dataset. This information, this so normalized it, and then latitude and longitude normalization, and then split x and y and modeling. Modeling we use a random forest, SVM and XGBoost, and we have seen that random forest and XGBoost are suitable for this dataset. And conclusion and feature work in this conclusion and feature work aspect of feature engineering involves extracting dates and time stamps, application of binding. Once the data is divided date-wise and R-wise, a time series analysis techniques can be applied to analyze crowd density. For example, T plus 1 where to T across various buildings. Overall, this approach allows to comprehensive examination of a crowd behavior, providing valuable insights in dynamic and changes in crowd density over time and across different locations. Such analysis can be beneficial for various applications, including urban planning and event management and crowd control. So that's all from my side. Thank you for watching my ML project, and thank you Sanjay sir for all the help.